Okay. Any question about what we did yesterday, guys, talking about grind circuits? We mentioned, Karen, yesterday that we're going to be circuiting, giving 17 lighting fixture on 120 amp, 120 circuit lights. And we're going to be doing 6 receptacles. You can switch it to 7 receptacles or 8 on one circuit, but we're going to stick almost, if we can, sticking with 6 receptacles in one circuit. That's the circuiting mechanism that we're going to do. An extra receptacle in one corner added to make them 7 wouldn't be a big of a deal. Okay, so with this, guys, we need to, when we deal with the electrical industry, we have to deal with receptacle switches. That's what you guys are going to be laying out with your friend Chad. You're going to be laying out switches for lights and receptacles for power. So Adam, my friend, what we need to do is talk about selection of switches. How do you select switches for commercial building as well as receptacles? We have rating for these switches and receptacles and applications. So when it comes to the commercial industrial, guys, you have to have rating as well as where can you use certain type of receptacles. We'll talk about these. Installation correctly of different type of receptacles. We'll talk about this one. Also, when it comes to three-phase, Karen, when it comes to switches, we have single pole switch. We have a three-way switch, four-way switch, as well as a double pole switches. We use them in the residential project, guys, with me. We're going to continue using them in the commercial project. Three-way switch, four-way switch, as well as double pole switch. Matt, any comments, any questions? Comments, questions, Adam? Comments, questions? What I want to remind you guys in this project, let me just, guys, there are 10 points for participation. So if I ask you and did not respond and I give you a list, then 10 points, please be aware of that. So I would like you to be with me. Cool. If I walk around and you're on your Facebook, that does not give me a good impression of your professionalism, right? So please, please be here on time. I haven't been pushing that one as much as I could. Yes, Adam.
What if you already went over this chapter last year?
You guys went over that one. I understand. But we're doing it from a design point of view. I fully understand. You guys went through. Your class went through. I know you guys, your class in particular, went through this because you were in an industrial project. I completely understand. But there's certain things, Adam, I would like you to be very aware of in terms of, for example, in a commercial project, we're going to be using a low voltage switches. So that's what I'm going to be emphasizing, going over low voltage switches that we haven't done. So just FYI, National Electrical Association, NEMA guys, you guys, I know Karen and Adam, you guys are special because you already did 2 years. So some of this stuff probably will be repetitive for you. We have NEMA guys develop standards for the receptacles and the plugs. Thanks God. Otherwise, we will be putting 15 amp receptacle and 20 amp 15 amp receptacle in a plug into a receptacle that rated for 30 amps. Different plugs and receptacles have to be rated for voltages and amps. The most important thing is a voltage and amps. So if I have a receptacle rated for 120 or 277 or 480, and you're going to have the ampacity of receptacles from 15 to 20 to 30 to 40 to 50 and so forth. So you would hope they will be configured differently. So when you plug in your equipment into these receptacles, you're not going to burn them. Very, very important, guys. I know, Adam, you guys wired a hospital grade receptacle with Mr. Lee. So hospital grade receptacle, guys, a major part of what we do. Location were severe. So hospital grade, there are 3 types of receptacle that we use in the industry, guys. Well, for the most part, we have the residential type receptacles, so cheap, 33 cents. You can buy them. Then they have tamper-proof now. They have the tamper-proof receptacle that we do. It's probably run you $1.20 or something. Then we have the commercial grade type receptacle. There's more robust, stronger, bigger. If you go to Home Depot or Menards, you find that they run you a couple of dollars versus $1. These are the commercial, and then there's a hospital grade receptacle. Again, they are more robust. They have to be identified as a hospital grade receptacle because of use and abuse and severe use and abuse. So that's it. In the commercial project, Derek, my friend, we will be using what we call it spec type receptacles. All the engineering firms, when you look at the specification that we have, they talk about spec type receptacles. A spec type receptacle is commercial grade receptacle, not the residential. So you're not looking at these cheap $1 or less tamper resistant receptacles that we use. So they do the same thing, 15 and 20 amp. They are make robust, more expensive, better application in a commercial building. You guys are wired this. I had to get you into the wiring system. So in a receptacle, guys, you're going to have a couple of locations that you have to pay attention to. If you have a color green into a slot of your receptacle, that indicated the grounding system. A silver will indicate your grounding conductor, and brass will indicate your phase. So this is your ground, this is your neutral, as well as this is your phase. Phase A, phase B, and phase C. That's how I identify them in terms of color coding: brass, white, and green on the sides of the terminals of the receptacle. The terminals of the receptacle. Electronic equipment receptacles, guys. If you have in this project, Adam, you will be having duplicate receptacle in a few seconds when I switch into laying out receptacles. I'm going to be talking about technology type receptacles. The technology type receptacles are meant to feed electronic equipment receptacles. When I get you guys to tie the two together, we have what we call them in our project technology type receptacles. They are here called electronic equipment receptacle. Who cares? They must have something called isolated grounding receptacle. These receptacle, guys, related to electronic equipment. If you type, when you're typing on your Facebook or what's not, instead of typing Chad and shows Karen on the screen, that's called noise, interruption, corruption of the data. So all these equipment, they handle electronic equipment from laptops into all these cashier machines and what's not. They require them in order to minimize the interference and the interruption and the noise, so-called noise, they call it noise, which is basically corruption of data. To minimize that, what they do is they run a fully insulated, isolated grounding conductor from the receptacle all the way down to the main panel. What's the job of this isolated ground receptacle or isolated ground conductor? The job of that conductor is to minimize the interference of signal interference with the operation of the electric equipment. Okay, so they have something, in order to do this, you have to have something called isolated ground receptacle. I'll show you a picture of that one. So when we start laying out in a second, like I said, technology circuits in our project, guys, be aware, fully aware, that these have to be so-called electronic circuits, electronic equipment receptacles in order to minimize the interference. With the isolated ground receptacle, you have to have an isolated ground conductor that take you all the way from the receptacle slot all the way to the main grounding ground into the main panel. You see in a second, I have a picture for that. Here's what you have. When you have receptacle, guys, you have two types of receptacles. I want to bring to attention to one little bonding jumper right here. Can you guys see that? Where is it here? It does not exist. That's the only type, the difference between isolated ground receptacle and non-isolated ground receptacle. In an unisolated ground receptacle, they bond the grounding conductor into the box. Can you guys see the whole bonding here? Into the box, into the conduit. That's what these receptacle you're looking at is designed. For the receptacle that says technology circuits in our project that we're going to be laying out in a few seconds, we call them, they're calling for an isolated ground receptacle in all the technology circuits. Did you guys hear me? All the technology circuits must have an isolated ground receptacle. What does that do for a living? You have to have, so what they do, guys, I don't know if you see, there's a little triangle here. But the manufacturer will, based on the specification, they put a triangle, an orange triangle on them, to identify that this receptacle is actually an isolated ground receptacle. What does that mean? Meaning, can you guys see the grounding slot here is not tied in any way, shape, or form to the box. And can you guys see where the green conductor goes? All the way down to the main panel. Who cares? By doing it this way, guys, and when you bring your laptop, now your laptop is sitting here, you're plugging your laptop into this receptacle. Now your laptop is not the information, or your laptop or server or cashier machines or what's not will not be corrupted. Why? because that conduit is not acting as an antenna, collecting all these noises. Noises are magnetic interference and radio frequencies and whatnot, and dragging it into the grounded conductor and dumping it right across the chassis of your computer. So anyway, by doing it this way, that will minimize the interference with your electronic equipment. Who cares? Your electronic equipment will work better, will not be interfered with. Any comments, any questions, Derek, my friend, about isolated ground receptacles? Any comments, any questions? So in all the technology circuits, we call them technology circuits that we're going to have, technology receptacles. In this project, they are asking you for the requirement, guys, about isolating ground receptacle. You hear this all the time, isolating ground receptacles. So unless they tell you it's an isolating ground receptacle, you do not specify an isolating ground receptacle. So this one here, can you guys see that little slot here? This will be built by the manufacturer. So you can't make a receptacle isolated or non-isolated. It has to be built isolated or non-isolated. Can I get you, Karen, to understand that one? If you guys look at the receptacle, can you tell if it's isolated ground receptacle or not? If I show you a receptacle. So what they do is the grounding, the chassis, the frame of the receptacle, that frame will be completely isolated from the grounding slot right here. Technology circuits. Okay, electronic equipment grounding. Why do they do this, guys? So when you have electronic, these what we call them technology circuits, they are susceptible to a couple of things: voltage sags, spikes and surges, and what's not, static charges, lightning. You want to minimize all this good stuff, and the most important thing, electromagnetic interference as well as radio frequency, and improper grounding and what's not. In order for you guys, anything that has electronic equipment, solid state, electronic equipment in it, we need to minimize, to increase the survivability of these equipment, we need to do two things, ladies and gentlemen. Number one, we need to have an isolated ground receptacle so we do not drag all the noises, the signals into the chassis of the equipment and make it interfere with the proper operation of this equipment. That's number one. Number two is also we need to get rid of the spikes and static electricity and what's not, and we do this one through grounding as well as through surge protective devices. So what they do in most of these equipment, guys, they have a surge protective devices. If the signal is coming like this, and all of a sudden we have a lightning that hit, the voltage goes so high, and it goes back again to normal. See that voltage? That means the transmission line got hit by lightning. It pumps the voltage so high. What they do is they have a surge protective devices that take the voltage, actually the current, and suck it down to the ground. So long story short, guys, all these from an isolating ground receptacle into isolating insulated grounding conductor, into surge protective devices, all these will maximize the survivability of your electronic equipment. And if you are the manager of a building and every time you have lightning you burn a couple of receptacles, a couple of laptops, you fully understand why they have this system. Any comments, guys? Any questions? Any comments? Any questions? Back to the project that you guys are going to be doing. We're going to be laying out quads in a few seconds. Your quads are called technology quads. They are required by the electrical specification narrative that we have to be two things: isolated ground receptacle and insulated grounding conductor, as well as neutral, a separate neutral. This is just for all receptacle, not just the electronic equipment, guys. The hot conductor, which is the grounded conductor, which is the neutral, as well as the grounding conductor, all of them must be properly sized, tightly connected, and correctly terminated for all receptacles. This article, this section in 250.118 lists all the means of so-called equivalent grounding conductor. I told you guys, when you have an electrical circuit, you have three conductors. If you get out of Dunwoody, not knowing that every electrical circuit, 99% of every electrical circuit have to have three conductors, ask me for refund. So when you have an electrical circuit, here's my circuit, lighting circuit. Here's my bulb coming in here. Here's my 20 amp circuit. Here's my number 12. That's your hot. Then you have to have a neutral to reference it. Here's my neutral, same thing. And then with this, you have to have another one that's called ground. This is called the three-wire circuit that we use, guys. Single-phase circuit. Three-wire single-phase circuit. Grounded conductor, ungrounded conductor, grounded conductor, and grounded conductor. So all these have been terminated properly, sized properly, and the grounding conductor, the equivalent, they call it equivalent grounded conductor, this one, have multiple means. Number one, you either have a conductor. Number two, do you see the EMP conduit right there? That acts as, the conduit itself acts as an equivalent grounding conductor. A different type of conduit, all metallic conduits, non-flexible metallic conduits act as an equivalent ground conductor. So inside that conduit, do you need an equivalent ground conductor? No. Do some people put an equivalent ground conductor in it? Yes, especially if it's isolated, insulated equivalent ground conductor. So what you do, if you have an isolated grounding system, is you have the conduit to ground the boxes, and you have another conductor to ground the grounding slot of the receptacle. So be aware of that one. Okay, moving into from the receptacle. So when you deal with the receptacle for our project Adam, when you start laying out, there are two types of receptacle. One technology, they're going to have an isolated ground receptacle and its own neutral, no shared neutral. That's what we're saying, and they're going to be in a different circuit. That's the technology receptacle, an isolated ground receptacle. There's the rest of the other receptacle, which is regular commercial grade receptacles, which basically one ground with them instead of two. Now moving into electronic, into the commercial project, guys. So we have the grounding as part of the protection. Then the second line of defense for you when it comes to the receptacle is ground fault circuit interrupter protection. These are required for all 15 and 20 amps, 120 volt receptacle in a commercial building. They can be in the form of a receptacle or in the form of a circuit breaker. These are so-called GFCI, your GFCI. Here's the location. When we were in the commercial residential, guys, I told you in a residential, countertop in the kitchen, unfinished basement, outdoor, you name it. In a residential. In a commercial, these are the receptacle, again, the amp-wise receptacle. That's going to be, if you put a receptacle in a commercial bathroom, guess what? It has to be GFCI. If you put it in a commercial kitchen, GFCI. On a rooftop, commercial kitchen countertop, in a rooftop, GFCI, within 6 feet of any sink, GFCI. So these are the location where require GFCI protection, guys, for a commercial building. Kitchen sink, within 6 feet of any kitchen sink, countertop in a kitchen, commercial kitchen, rooftop, anything outdoor, anything in a wet location, any sequence book, guys, required to have GFCI protection. What's a GFCI protection? If somebody's to get in direct contact with the phase, instead of the current going through their heart and sending them to the Lord, what the GFCI will look at the current that coming in, the current that coming out, and if there's a substantial difference between them, it trips. Where would the substantial difference, guys, between the current going to the lamp and the current coming back from the lamp? If there is substantial difference, 5 milliamps, that's going through my heart. So that electronic device will trip and interrupt the flow of the current through somebody's heart and save their life. Any comments, any questions, guys, about GFCI protection? Like I told you on Monday, we're going to have our first test. There will be a question about the location that require a GFCI protection in a commercial building, because we finished residential. In a commercial building, we need the location of the, where do you need GFCI? This will tell you, guys, this section in 406, it will tell you if you are to replace a receptacle right now in a commercial building. You guys you're not electricians. If you replace a receptacle in a commercial building that require a GFCI location, you have to replace it with a GFCI. That's code requirement. If you also require a receptacle that need weather resistant, it has to also be weather resistant. So that going into the maintenance. If you have a built baseboard heater, what they do, guys, in a commercial and residential, they have baseboard heaters, and what they do is they have built-in receptacle in a baseboard heater. Two things: if you have built-in receptacle in a baseboard heater, the receptacle that you in it shall not be connected to the heater circuit. So if you have a built-in receptacle in a baseboard heater, you have to have two circuits: one going to the receptacle and one feeding the heater. And for the heater, fixed baseboard heaters, We size them as 1.25, and you guys did them with me, times the full load amp of that piece of equipment. And of course, that receptacle will be part of, it will act as a wall space receptacle, a receptacle for a wall space. Any comments, any questions? What happens, guys, to heat the area? Sometimes they have baseboard heaters, electrical baseboard heaters. Then you have no room to put a receptacle. So the smarter than Chad years ago, they design a baseboard heater with a receptacle. The only thing you need to pay attention to, now you're looking at two circuits, one for the heater, one for the receptacle. Any comments, any questions? Matt, does it make sense? With a couple of things. Derek? So these are the things that you guys have to know about receptacles. So to summarize, you need GFCI location for receptacle in a commercial building. Typically, any place that has wet location, they have to be GFCI. You are using something called spec type receptacle, more expensive, more robust, capable of being abused more everywhere. You are for technology circuit to use so-called isolated ground receptacle with an isolated insulated grounding conductor. And most of the receptacle, almost all the receptacle that we use in a commercial building, Atom R, 20 amp, 120 receptacle. You wouldn't use 15 amp. Though there's a lot of 15 amps. A 20 amp receptacle are the best, I didn't say you wouldn't use by code, but it's a good idea to put a 20 amp receptacles. Okay. Then we move into the switches, guys. The switches that we're going to be using are 15 and 20 amp switches. 15 and 20 amp switches. They're called snap switches. A lot of people call them toggle switch. You're looking at a few of them right on the wall here. Toggle switches. Also, these toggle switches, guys, Adam, they are also, when we do switches, you can have two types of switches that you can buy. Switches that are so cheap that I can put in my basement for 33 cents or 50 cents. The ones that Michad Cooley Erickson and other engineering firms specify, not the cheap receptacle, the residential type. They call them spec type devices, spec type receptacle. Who cares? They're bigger, more robust. They can handle the interruption of the current better. Did you guys hear me? Same 15 or 20 amp receptacle switch. One of them will be cheap, typically made for residential. The other one will be more robust, a little bit more expensive, made for the commercial industrial. They do the same function, and they're all 15 or 20 amp switches. Switches, guys, there are two types. The most important type, of course, the AC general use snap switches. That's used on AC only. You're looking at it right there. And if you're switching DC, Adam, if you didn't play the DC with us, if you're doing DC, then your switch have to be rated to interrupt DC. Most of what we do, guys, well, things are changing though. Most of the switches that we design are rated for what? AC. Why? Because we distribute power with AC. Now the solar photovoltaic system is coming a lot. There might be loads that are fitted at the DC level. So when you have a switch on a DC circuit, make sure that your switch is rated for a DC switch if you are to install it in a DC circuit. Grounding with snap switches in 2009. Probably some of you guys were in grade school, huh? 1999. In 1999, what grade were you at, Matt? 1999. Fourth grade? Oh, gosh. My God, you guys make me look old. Oh, sixth grade somewhere? Oh. Okay, at that time when you were playing with your toys and Elmo and all the other stuff and sucking your thumb, or you probably wouldn't be sucking your thumb at that time. The NEC code book came with a major change that you didn't care about at the time. Now you're a professional electrical field, you have to. They're telling you every switch have to be grounded. So in the past, guys, they used to have a switches without a grounding slot to ground it or terminal. Now every switch have to be grounded. So so for switches, if you have cables going to them, you have to ground the switch, ground the middle face plate of the switch. The box has to be grounded. So if you have a metallic box, when you bring a grounding conductor with it, you have to ground three things. Number one, the box itself. Number two, the switch. And number three, the plate, if it's metallic plate. This is not metallic plate, so we don't care. Can you guys see these screws here in these little screws right here? These will ground a metallic box. The switch itself need to be pigtail so you can ground it. Pigtail the switch to ground it. And the box itself also have to be grounded. If you have an AC, an MC cable, guys, you will ground the box and the plate and everything else will be grounded through the grounding conductor that comes with these babies. Metal yoke of the snap switch also have to be grounded. Like we said, snap switch is considered grounded when they're secured by metal screws. You secure them with metal screws. That's also to a metal box that will be grounded. You don't have to pigtail them. Metal faceplate is considered grounded when you attach it to the yoke of the switch. So any comments, any questions, guys? I know you're not an electrician. Now, Derek, you're going to be a project manager. So as a project manager, knowing what the code requires for grounding is a major thing. You can check and inspect your own work, right? Before the inspector shows up. So long story short, receptacles, switches must be grounded, the device itself, the cover, as well as the box. If they're non-metallic, you pigtail them. If they're metallic boxes, you depend on the contact, the metal-to-metal contact of the switches and the plates to be grounded. The NEC code book, guys, mandates certain color coding for conductors when it comes to it. Changing in 2014, ungrounded conductor. They tell you for ungrounded conductor, guys, you can use the following: anything that is not white or gray or three white stripes on other than three white stripes. If you have other than gray or green, So let's go through the color coding before you guys. Number one, for the grounding, equipment grounding conductor, guys, you use green or you have to use green, right? So that's your green or bare conductor. White and gray and three continuous white stripes on other than green. These are grounded conductor, then neutral. How about the phases? The phases color, guys, can be any color other than these. That's what the code tells you. So for a three-phase system, here's the color code that they use, guys. They use black, white, red, blue. Black, red, blue, and white. This will be for the system 208/120 three-phase. For this color, guys, and that's guaranteed on the test, gray, orange, yellow, brown, orange and gray, and of course green for the grounded. This will be for the 480/277 volt three-phase system. Any comments, any questions, guys, about the color coding for the conductor that you have for branch circuits and feeders? If it's a grounding conductor, it's green. If it's a grounded conductor, either white or gray or white stripes on any color other than green. I'm sorry, other than white or gray. If it's all the other phases, the hots can be any other color, but the most common ones, guys, are black, red, blue, white, and yellow, brown, orange, gray for these two different, plus green, of course, for all these two different voltages. Any comments about the color coding for the system? Any comments, any questions? Does it make sense? No, yes? Okay, so that's your color coding. If you're ungrounded conductor, guys, a lot of ungrounded conductor sizes number one and larger come in a black. So how do you do it? Now they have a lot of color coding. So what if I have 4-aught? If you want to buy 4-aught, the cheapest 4-aught, well, things are changing though. It's going to be black. You're going to 4 black conductors. So what do? If you have 4 black conductor, guys, you go leave one of them black, put a tape around the other black, red tape, and blue tape, so that will give you 3 conductors, phase A, phase B, phase C, and the neutral also another black but white tape around that conductor 4-aught, and so now four black conductor you buy, right? Because they're feeders larger than number 6. You can re-identify them in the field if they're larger than number 6. So 4 black conductors. One of them stay black. The other one you put a tape, red tape on it. The third one will put blue tape, and the fourth one will put a white tape. And you got yourself a 3-phase 208/120 system. Any comments, guys, about re-identifying the feeders and the branch circuits in the field? If your conductors are number 6 or smaller, you can't do that. They have to be color coded. Smaller conductor for branch circuit, number 6 and smaller, they have to be identified, color coded. You cannot put tape or tag on them. Okay, so that's a grounded conductor. Have an outer finish of either continuous white or gray color, or having outer finish that has 3 continuous white stripes. Okay, the grounded conductor, like I say, gray or white, or 3 continuous white stripes on other than green. Any comments, guys? Any questions about identifying the color code for your conductors? Code for conductors. So important in a commercial building to do that. So this is just, you guys are not electricians, but to be a project manager, I always say, guys, to be a project manager, designer, the more installation you know, the better designer you will be. No question asked. So telling you the equipment grounded conductor shall not be used, never used as an ungrounded conductor. The ground never used as a hot. That's basically. Okay, typical color coding, conduit wiring, color coding is not code mandated. We talked about the colors that they can use, guys, for conduit. White and gray again. White and green and green. This is your ground. These two are your neutral, right? Permitted to be used. Color coding. In the past, you guys don't care too much, you're not electrician, but in the past, believe it or not, the gray conductor was used as a hot conductor. So if you're doing troubleshooting, I don't know, Adam, if you do any troubleshooting work, if you go work in a building and you find a gray conductor, be very careful, made in the 40s or the 50s, that gray conductor might be hot. Now it's a ground, but in the past it used to be hot. If you have 2 electrical systems in one building, the building that you guys have with me, it's the 15,000 square foot building, has only one voltage system, 28120. If you have 2 voltage system, that's a commercial project. We're going to have 25,000 square foot manufacturing floor. We're going to have 2 levels of voltages, 28120. So if you have a voltage 480/277 and 208/120 volt, these are 3-phase systems. So what they do then, what you have to identify the color coding. So the white conductor goes with this. The gray conductor typically goes with this. And so you use the grounded conductor will be 2 colors. One goes with every system. Why do you think they care? Because the last thing you want to do, you have a box, has 2 whites, and you have no idea which white goes with which system. Wouldn't that make a difference? If you pick the white, guys, that goes to this light, and this lighting fixture is rated for 120, and you brought 277 across this lighting fixture, what do you think is going to happen to it? You just burn it. So if you have 2-volt electrical systems in one building, you're supposed to identify by color. Actually, you're supposed to identify the phases, all the phases, the grounded conductor, the neutral, if they enter the same box or conduit. If you're using different boxes or conduits, you don't have to do that. Any comments? And you also have to label. Every panel have to have a label that says, by the way, 28120 color code is black, red, blue, and white. And then on the panels and right next to it, a 480/277 system, guys, is running as an orange. What did we say? We have an orange, yellow, and brown. Brown, orange, yellow, and green. See, these are the colors that you have to identify them. For cables, when you use cables, typically they have the same color coding, limited the amount of colors that you use. But if you use an MC cable, Adam, you're going to have an MC cable with 28120 colors or 480/277 colors that you can use too. You have multiple colors that you can use, not as much as conduit and wire. For wiring methods, Karen, there are 2 ways you can wire a receptacle. You can bring a conduit and a wire to it, like this right there, or you can bring a cable to it. Both of them have to adhere to the color coding of ungrounded conductor, grounded conductor, and grounded conductor and grounded conductor. Okay, if you're wiring with conduits, the possibility is endless, guys. You can have so many colors in a conduit. It's almost the same thing. For cables. The issue becomes, guys, return for the switch. How do you identify the return for the switch? We'll go into this one right here. Okay, here's the wiring methods. If I take you guys right now in the lab, I would hope that I know, Matt, you haven't wired some of these, so probably I'll be taking you at one time later on to do some wiring. But You bring the home run, guys. You're bringing, here's the schematic for it. Here's the real wiring. I have a conduit. I brought the hot and neutral, black and white, into the box that has a receptacle. What you did, guys, is you brought the hot into the receptacle, supply and return goes into the light. So sublight the switch, return as in your red, black, red, going all the way back. Now this, if you have a cable, the same thing. Can you guys see that? Now if you bring your circuit, if you bring your home run to the light, then you have to get into re-identification. If your conduits, if you're doing conduits, you bring 2 color conductors. If you're doing a cable, in 2011, they start requiring us guys to have a neutral on every box. Since I need a neutral in every box, basically use typically, if it's, you're going to use 14.3 or 12.3 on some of these receptacles, you're going to have a black, red, and green. Black, red, and white. Any comments, any questions about wiring? You guys know how to wire these? Now knowing it, you guys are designers, knowing how to wire them is, you're not going to be wiring them, but if you know how to wire them, they're going to do takeoff. I want to remind you, Karen, you will be taking a takeoff on this piece, cables. So knowing what the type of the cable, how many conductors, and what type of box, guys, is so important when you do estimation in the spring, so you can do the takeoff. Snap switches, guys, have different types. I have a single pole snap switch. That means 1 hot. I have 3 and 4-way switches. That's just to give you a different mechanism. And I have a 2-pole switch. That's hot 1 and hot 2. So if I want to switch a circuit 277 or 277 or 120, you're looking at single pole, 3-way or 4-way switches to give you more mechanism. If you're looking to switch a circuit 208 or 240, you're looking at 2-pole, double pole. Double pole, switch 2 hots. Single pole, switch 1 hot. 3-way and 4-way switches, they switch 1 hot, but they switch it in a way that can allow you to switch it from multiple locations. Did you guys hear me? Everybody understand the difference? Single pole and double pole, single phase, 2-phase. But 3-way and 4-way switches, this is just to give you a different mechanism of switching the circuit, different mechanism. Occupancy sensor. You guys with your friend Chad, not next week, the week after, we're going to be talking about lights. You will hear about occupancy sensor. Occupancy sensor, electronic devices that sense your movement. They listen to you and they watch you. They literally, they have listening ability and watching ability. Listen to you, watch you, you walk, and they sense that your presence. They turn the light, keep the light for 15 minutes. Nobody moves in that room or whatever you set it up. They turn you off. So that's what we do with the occupancy sensors. You guys will be using these. The occupancy sensor will be used in place of switches more and more. Derek, in a commercial building, we're moving away from switches in the wall, and we're moving into occupancy sensor in the middle of a ceiling. Why? Because we're going to be environmentally friendly people and save energy and save Mother Life, Mother Earth for future generation, your kids and my kids, and so forth, right? Exactly like what happened to the receptacle when you were just playing with toys, they're grounding it. Now other kids are playing with their toys, and you're the professional who are going to set the stage for them, right? So they can have enough juice on the earth to power their equipment. Any comments, guys? Any question about occupancy sensor? We do have a speaker that comes talk in details about occupancy sensors for you. So why do we have occupancy sensors? The name is energy, saving energy. Green as in green energy, green control. Switches, receptacle covers. So this is just about the faceplate cover placed on the recessed boxes. Race cover, have to have race cover. Cover shapes and materials, 2 carriers, metal, and insulating. When it comes to the plates, guys, the most important thing, look at that there. You can either have it metal or insulated. Most of the stuff in a commercial building is insulated type. If you go to an industrial building where there's a lot of abuse, the cover itself becomes metal. Metal faceplate are effectively grounded. If you use the plates, guys, you have 2 screws, and these screws you attach them to the yoke, and by doing this one or 1 screw, if it's a receptacle, by doing this, attaching it to the yoke, you have just grounded that receptacle. If you have a non-metallic yoke, you have to ground it directly. If you have boxes and cover installed in a wet location in 2000, oh, that has been for a while, guys. Any receptacle that installed in a wet location must be, listen, for anywhere. They have to be in use covered. You guys see that bubble that you put your receptacle, you plug in and still bubble sitting like this? In use cover, they call it. It has to be GFCI protected, and it has to be in use cover, GFCI protected, and weather resistant. 3 things for every receptacle that you install outside in a commercial or residential building. Weatherproof, or you have to have, of course, weatherproof and weather resistant. Weatherproof enclosure and weather resistant type. Weather resistance came in 2008, I believe, or yeah, 2008. So the most important in damp location too. So then becomes, guys, damp location, dry location, wet location becomes a big definition for them, because if you install a receptacle in damp or wet location, this receptacle have to be weather resistant. Weather resistant receptacle, Derek. You fixed your light yesterday? Were you able to fix your light? No, you didn't show up. Do you need the ladder? Drive to Bloomington. I'll give you one. My God. I have one that can go like 35 feet off.
This thing is like well over 30 feet in the air.
So where do you live, in the church or what, man? What type of a building is that? A house?
Got a steep slope.
Wow. Interesting. So because of all of this, guys, they used to put receptacles in the past and outside. They're made from a material that can be affected by the heat and cool. And I did it many times. You go to change a receptacle, I know how many of you, and it falls right in your hands. Anybody have done that? Falls right into your hand. So they're not making it more robust to handle the heat and the beating that happens from the sun. So what was it, 2008, I believe, they start requiring all your receptacle to be weather resistant in damp and wet location. Here's what damp location, guys. Location protected from weather. So if it has to be protected from weather, not subject to saturation, to not a whole lot of water, with water or liquid, but subject to moderate degrees of moisture. Basements, porches, considered damp location. So these are the damp locations. A dry location, obviously, you're looking at it. A location not normally subject to any dampness, not subject to any dampness in this room like this, or water, what's not. Wet location, the key word for wet location is, guys, saturation with water. Installation underground is called wet location. Concrete slab, of course, in direct contact. Masonry, in direct contact with Mother Earth. So the key word, I always, when I teach this, when I say the word saturation with water. Any place that there's saturation of water, it's a wet location. Car washing places, right? Any place where they use water on a regular basis, inside or outside, obviously outside because of the rain, it's called wet location. Who cares? When we put a conductor there, guys, it has to be rated for wet location. When we put equipment there, it has to be weather resistant, in use cover, and enclosure rated for that location. Does that make sense? Fixtures, receptacles, you name it. So these are the most important things about the wet location. Let me show you a couple of pictures here, and then I'll switch into CAD. Any comments, guys? Any questions? Comments, questions? Any comments, any questions? Karen, any questions, any comments? So the rest of it is just a couple of pictures, guys. Here's the slot that says white. Oops, this is my white, of course, for the grounding conductor, for the ground conductor. That's your green for the ground equipment ground conductor, and that's your hot for ungrounded conductor. This is the configuration that NEMA came up with, guys, for a 15 amp 120. Here's a 15 amp 20. I don't know how many of you guys are all familiar with that one, of course. This will be 15 amp 20. Now, do you need to memorize this one? No, because they're all there. Different voltages. Can you guys see different slots will give you different configuration based on the voltages? We talked about this one. Here's how they do isolated ground receptacle, because probably new to some of you. I want to bring to your attention, guys, can you guys see the grounding slot that came out of here all the way to the surface? That's how they call it isolated ground receptacle system. Isolated ground receptacle system. Any comment guys about isolated ground receptacle? Isolated ground receptacle. I want to bring to your attention that orange triangle required by code right in here, orange triangle, or the face, all the face could be orange. So that's my isolating receptacle. This is just a few things about single phase and three phase signal, guys. Single phase and three phase signals. How the three phases come together to get you. I don't know how many of you guys, when you were, who taught you basic electricity? Holly? Holly taught you, or who taught you? Was it Amy?
For a little bit, and then
Oh, you guys are the ones that we switch. So look at this. This is your 208/120 volt system. So I don't know if you guys can see when for three-phase system, that will be equivalent to all this. It's almost like a DC right in here. You can ignore this. And it's like having a DC voltage right here, equivalent to 208 volt multiplied by 1.73. That's how a three-phase system. It's like the three phases will be equivalent to 208 times 1.73 DC system. Spikes in your system, that's what you need to protect, Adam, when it comes to electronic equipment. Take this. You're beautifully running, and all of a sudden, all hell break loose, and you have lightning hit your transmission line, surges. Can you guys see these called surges? These surges are supposed to be sucked, minimized, dropped directly into Mother Earth in order to minimize the damage to your electronic equipment. So that's where you use TVSS and what's not to minimize your equipment. Here's how you wire receptacles and lights on a three-phase circuit. I can't emphasize this, especially because a lot of you guys we haven't started wiring on three-phase circuit. I can't think of a better picture for showing how do you wire receptacles and lights on a multi-wire branch circuit or single branch circuit. Can you guys see at the top? Everybody can see how you wire your lights. You have, so what you do is you have your 20 amp circuit here. They don't have to be tied together, as a matter of fact, because you have separate neutral here. So you have a 20 amp circuit here, and the voltage is 208/120 or 480/277 volt, right? And then you take a phase. Can you guys see how they're taking it? Let's start with this. This is phase A, phase B, phase C, phase A, phase B, phase C. Can I have thumbs up, Chad? We fully understand how to circuit with three phases. Adam, makes sense? Circuit with three phases. Derek, Matt. So they take one phase and neutral, and circuit with three phases for your lights. For receptacles, no difference, guys. Can you see that? They're having an individual neutral. So this will be in phase A, this will be in phase B, phase C, phase A, phase B, phase C. Why am I emphasizing this? You guys are going to be doing layout of receptacle in a second with your friend Chad. That's how you're going to be doing it. You put your receptacle, circuit them. The first circuit will be in phase A, phase B, phase C. And when you number-wise, this will be 1, 3, let's just say 1, 3, 5. This will be 7, 9, 11. And this will be 2, 4, 6, 8, 10, 12. So these, can you guys see how they run three-phase circuits? They run them all the odds on the left, all the even on the right. So in order to get phase A in the odd, you have to put 1 or 3 or 5. In order to get it, phase A is 1 or 2 will get you phase A. 3, 4 get you phase B. 5 and 6 phase C. 7, 8 A. See how it starts repeating itself? These will give me phase A. Here's phase A again. Can you guys see that? To get phase A, how they're laid out, all the odds, all the evens, and that's how we circuit them. Both and where? Can you guys see on the receptacle or on a lighting circuit? Any comments, any questions? Any comments, guys, about circuiting? I can't emphasize how important this picture is. How many receptacles we're going to put in one circuit? 1, 2, 3, 4, 5, 6. Exactly 6 receptacles. Now, right now on one circuit, so this will be 6 receptacles here, 6 receptacles, 6 receptacles, 6, 6, 6. 1, 2, 3, 4, 5, 6 times 6. 6 times 6, how many receptacles? 36 receptacles on a three-phase circuit. 3 huts, 36 receptacles. That's the design criteria. If you want to go the maximum, 13 receptacles in 1 hut. Light, let's go talk about the lights. I told you guys to use 17 lights, 17, 17, 17, 17, 17. So each one of these 17. Derek, do me a favor, will you? Take the 17, multiply them by 6, and give me what the answer. Do you have a calculator handy?
51.
How much?
51. 17 times 3.
Times 6.
Always have 6.
Yeah. 1, 2, 3, 4, 5, 6. 17 times 6. Anybody has a calculator? Handy? I'll give you how many lights. 102. So you can have 102 lights here on this system, and you can have how many? 36 receptacles on this system. Again, that's design-wise. You can go code-wise. You can go up to 13 receptacles in 1 circuit. Any comments? Any question, guys? How we circuit 3-phase? I can't emphasize this enough. I can't emphasize this enough. So that's your receptacles and circuiting. The grounding, why do you use GFCI? You guys seen it on the residential project as well. They have an electronic circuit that senses what's going on. If the current is 6 can you guys see 6 amps going on here? There's a difference of 6 milliamps going back. That difference is going right to this gentleman's heart. The electronic device have a sensitivity to sense, guys, and measure and say, wow, there's a 6 milliamps going where? Through somebody's heart, and it trips fast enough, so this gentleman will go back to his family. So how do they do that? The Smarter Than Chad have electronic inside. Can you see all this junk here? Inside the receptacle that you're looking at, the push button and what's not. Any comments, guys, about GFCI? How do GFCI work? They measure the current that goes out with the goes in, compare them together. If there's a difference of 6 milliamps, 5 to 6 milliamps, they trip. How do they trip? Can you guys see that thing here? They open this. When they open, now there's no more current flowing right somebody's heart. Can I have thumbs up, Chad? We fully understand GFCI for residential, commercial, or anything else. Okay, so that's where it's required. We talked about baseboard heater, guys. That's what they mean by baseboard heater. You can have, the only difference is you have to have one circuit here. This is circuit number 1, panel -1, and also another circuit. It's going to be coming to this heater. This is circuit number 3 and 5 from panel number 1. Can you guys see that? The baseboard heater, they're built in, but you give them 2 different circuits. Can I have thumbs up, Chad? That's how we do with baseboard heater. Okay, awesome. Grounded system, this is just to give you an idea what we talked about these systems that they use, guys. I'm not going to talk about these because we did them in residential, these 2 systems. The most important system that we use in the US, guys, is this system right here, which is 208/120 volt and 480/277 volt. These are all 3-phase, and 3-phase. This is the most important system that you guys are going to be doing with me. Can I have thumbs up? This is called 4-wire. Why 4-wire? 1, 2, 3, 4. Center 4-wire grounded system. 4-wire grounded system. That's it. That's probably 90% of your systems. These 2 systems, guys, are rarely used. This one is probably 10% of the time used. We'll talk about them in the commercial project. Any comments, guys, about the systems? Derek, when they talk about system, the system and the power system always start with a transformer. That's your coming from the utility. That's decide what type of system do you have. Is it 208/120? Is it, for example, this one is 480, grounded, corner grounded. This one is center tap. This is typically 240/120 3-phase system. So these are the systems that we use. The most common one is a 4-wire. We talked about this one, guys, and all the requirement for this. So, Adam, I know you guys are not designed right now to be an electrician. I want you to fully understand, when we do takeoff in the spring, I'm going to look you in the eye and you're going to tell me, you're going to come here and do takeoff. And when you do takeoff, you're going to decide how many conductors are going to be in this wire to do takeoff. I know you guys are not an electrician, but you will need to know how it wires. So if you don't know I know you did. I know you did. Derek, did you guys do some wiring? A little bit. Matt, you haven't done anything. So probably we'll take, because we're switching, I'll take you to Karen's lab and we'll do some 3 and 4 wire, simple wire, 3, 4, and what's not. But you need to be aware that this is how you bring the circuit. For example, you bring circuit to a box, you bring the neutral to one slot, the hot comes in, tabbed, go to the supply side, return into the lighting fixture. That's how power system works in reality. Schematics, how is schematics for it? It's right in here. That's what you guys, the series parallel circuit that you did with Amy and what's not. You can bring the circuit to the switch, like here, or you can bring the circuit to that light, like the one underneath it, with a conduit or a cable. 3 and 4-way switches, guys. This is the identification of a 3-way switches. These are called travelers. When you have travelers, guys, so easy. You just tie the travelers together. When you wire a 3-way switch, all what you have to do, they call them travelers. You tie the 2 travelers together, and you put your lighting fixture right here. Look how easy that to. So bring that one of that. So tie together. Bring one of the terminals to the light, and if you're bringing your power, so let's say my power is coming from here. Bring my power in here. Is my hot. My neutral is right underneath it. Is my neutral. So then my neutral, I'm just going to use a different color here for it. My neutral will continue here and go here and go all the way to the lighting fixture. Gentlemen, you have the schematic diagram for a 3-way switch to turn a light on and off. I want you guys in the back of your book, did you guys hear me? In the back of the book, there are wiring diagrams. I want you to do all of them. I want to make sure, when I do it, draw them on the book. You don't have to draw them on a sheet, but on your book, please sketch all these wiring methods. Different type of wiring, guys, giving you 3-way switches. So as you go, why we care about the wiring? This is how a 3-way switch is connected. Can you guys see the travelers tied together? And then one side goes to the light, one side hot goes to the hot, and the neutral goes directly to the lamp. This is how the schematic of it. You can bring the circuit in here. Can you guys see if you bring the circuit to the light? Then you have the continue. I can't emphasize. Can you guys see how they identify these blue as white, and they brought the travelers? These 2 are these 2, these 2 are these 2, right? And then they brought the hot into this switch, and the return is coming from that switch. The schematic for it, if you're using a cable or if you're using a conductor. If you're using a conductor in 2011, guys, you're required to bring a neutral. You are, as of 2011, are required to bring a neutral. Guess what's happening, Adam, in 2014? There's exception for this. Where if you have a 3-way switch, you can bring a neutral only on one side. One more time. If you're wiring with cables, you have to bring a neutral to every switch. If you're wiring with conduits, you don't, because you can pull a neutral at all times. Why do we have to bring a neutral to every switch? Because people are changing their snap switches, guys, into occupancy sensors, right? If you want to put an occupancy sensor right here, and you don't have a neutral, the only way you can get returned to Mother Earth is through the ground, and that's unacceptable by the code. Unacceptable. Here's the 4-way switch, guys. 4-way switch, very simple. You take 2 terminals of every 2 timed together. Can you guys see that? Terminals timed together. So if I have a 3-way switch coming in here, tie these 2 together out. If I have another 3-way switch coming in here, tie these 2 together and out. Here's your 3-way and 4-way switches. Now, Derek and Adam and Matt, the reason why we have a 4-way switch, so you can get multiple locations switching. 3-way switch and 4-way switch in a commercial building is not commonly used, guys. Unlike residential, you don't want to do it. Why? The energy code will force you. Did you guys hear me? The energy code will force you to use occupancy sensors and what's not. So here's a wiring diagram, guys, for 3-way and 4-way switches. I'm going to bring the schematic right here. The first thing you do, Adam, is you tie, and Matt, you tie the travelers to the travelers. Can you guys see that? You take 2 between the 4-way switches and the 2 3-way switches. And then you take from one side, you go to the lamp. From the other side, you go to the hot. That's the rule. And the neutral goes right through it all the way. Right through it all the way. If it's a conduit. If it's not a conduit, the neutral have we, as of now, terminated in each and every one of them. Any comments, guys? Any questions how to wire 3-way and 4-way switches? So Matt, you would remind me in the spring to take you there and we do a couple of 4-way and 3-way switches wiring. It's really not rocket science. All what you have to do is identifying the conductors and which terminal to go to. This is a two-pole, guys, double pole switch will switch phase A and phase B. That's the difference. Single pole versus double pole. Single pole versus double pole. You can always switch the neutral to as a pole, but typically it's meant to switch to two hots. That's why we have a double pole. Not commonly used, but you can use it. A couple of receptacles, guys. The rest is just different type of receptacles that you use in the industry. So here's the different type of receptacles you're familiar with. Does it look like? Okay, single pole. Here's your 240. I don't know if you guys can see it right here. 20 amp, 125 rated receptacle here. You can see the slot here indicated as 20 amp. This receptacle is your 20 amp, 125, 20 amp, 125. Receptacle one receptacle. This guy is your 240. Is a 30 amp NEMA 630, guys. That will be 30 amp. I don't know if you guys can see that. 30 amp 250 receptacles. This is a hospital grade receptacle, Adam. It has a green slot on it. This indicating that's a hospital grade receptacle. This is an isolating receptacle, guys, meaning the yoke and the slot here are isolated from each other, so you can identify them. Lots of decorative receptacle, guys. It looks like this is a surge protective or what's not. So you can have surge protective devices and what's not. Here's what amounts to spec type switches, guys. Does that look like the one that you use in your house? Do you see the skinny ones that we use for residential? Can you use them in commercial? Yes. Should you use them in commercial? No. They're more robust, the one that we use, the switches, different decorative light. Anyway, so you can see, guys, the 15, this is a 15 amp type, what looks like a 3-way switch. Occupancy sensors and motion detectors and what's not. In-use cover, a hard cover, in-use cover, guys, I use outside. Here's in-use cover for receptacles. This is for damp location. This is for wet location. Can you guys see? You plug it in-use cover. The last thing I want to talk about, guys, the NEMA configuration. All of you guys have seen this one right in your page. I want you guys, this is how NEMA make sure when you go to Texas and you plug your laptop, you don't burn it. But if you go to England and you plug your laptops are rated for a lot of them, you plug something that you buy from the US in England, you better pay attention to the voltage configuration, right? Anyway, so it starts with the amps here, 15, 20, 30, 50 amps, 60 amps. This will be on your test, guys, just FYI. They will give you, if I have a two-pole, two-wire, 120, this is how it looks like, two-pole. The most common ones, guys, are right here. It says two-pole wires with a ground, because everything is with a ground. Here's your 120 system. It's called 5-15R. 5-15R, that's a receptacle that you can see right in front of you, right here. That's a 15 amp receptacle, 120. 5-15P, R for receptacle, P for anybody, what goes in the receptacle? Plug. That's how NEMA rate them, very simple. 5 is the NEMA number, 15 is the amps, R for receptacle, and the voltage for this is 120. P is the plug. That's how they guarantee, guys, in the US, the manufacturer. You can go anywhere. If you have a 15 amp receptacle, it will match a 15 amp plug. Otherwise, you're going to burn a lot of equipment. Anyway, if you guys go, here's a 20 amp receptacle, 20 amp plug, 30 amp receptacle, 30 amp plug, 50 amp receptacle, 50 amp plug. Can you guys see that, please? Everybody can see that? So that's, then if you go here, here's your 277, here's your 480. These are two-pole, three-pole, these are three-phase. Three-phase, guys, this is here three-phase, phase A, B, and C, right? 120, 250, three-phase. This is how the configuration that they do them. Here's X, Y, and Z. They start using X, Y, and Z for the phases. Here's a three-pole, four-wire receptacle. That's common.
3-pole 4-wire. If you guys look at 3-phase 250, look at this. I have with a ground right here. I have X, Y, Z, and G. X, Y, Z, and G. 4-wire. I don't know with the ground or without the ground is. So they have different configuration for different voltages and amps. All this to make sure that you do not plug a receptacle, a plug, in a voltage higher than what is rated for, or lower, or an amp higher or lower when what that plug is rated for. So these guys are these ones are the we have oops, going too fast here, and that one. There you go. So these are your receptacles configuration from NEMA. Locking, these ones are called locking type receptacle, guys. Configuration for the ones that lock here. You're looking at it right here. You see that locking type receptacle versus the one right in front of you. These are configuration for, I'm sorry, this is the non-locking type. This one, the second one, is the locking type receptacle. You can see the difference here. They're kind of, you plug them in and you lock them for safety. Anyway, so that's, please look at these. You don't have to memorize it. In the industry, Adam, you'll be surprised. You will have, we have a plugs, guys, rated for 200 amps. So special type plugs. So we have a lot of plugs. This is what they talk about. How do you think of this as a plug? This is a plug, NEMA plug. And this has 200 amp, 240, 123 phase. So what would you do something like this? Say a building ran out of power. They threw a generator outside, rent power. They come up with a cable like this. They plug it into a machine, and they cable it all the way to the Dunwoody here, and they power you temporarily until you get your power, fixed power. If you have carnivals, and you probably see a lot of them for a lot of 200 amp, 3-phase, 250 system. That's how big these receptacles. So you can appreciate. This is a female plug. They call it a female plug, and there is a male plug. Male plug will be. These are female plug. They call it. So anyway, so that's what NEMA. I don't think this will be even here because can you guys see? This is 60. It goes only up to 60. If you go higher than 60, like 200, 400, you have to go manufacturer specification. Okay, so that's the rest of them, guys. Do me a single favor. The rest of them is, I would like you guys to take all these and wire them. Could you please do all the wiring for these in the back? You guys have seen them. I'm going to do very quick one of them. 3-way switch. I don't know how they want it here. I'm going to do this one very quick, guys. Let's come up, and then I'll let you go. 4-way switch? What's 4-way switch? Yeah, 4-way and 3-way. Can you guys see? It's 4-way and 3-way. Let me show you guys. Here's our 4-way. How am I going to say it? This is my 4-way. This is my 3-way and another 3-way. And here's my light. Okay. Adam, where do you want to bring the power? Pick a location. Do you want to bring it to a switch, to the light, or to any of these switches? Make it simple. Don't bring it to the 4-way switch. Where do you want to bring it? To the left. Okay. Adam decided to bring his power to here. Here's the power. Here's hot. The first thing you do, guys, is land the hot right in here. Cool. The second thing you do is you take this one from here to this point, and you take the oops, why am I off? From here to this point. So these are the terminals that you're going to be using. Can you see that? I'm off a little bit. Here you go. Here. There you go. So that's the hot. Now we need to continue with the hot, guys. I'm going to continue with this. Can you see that? Coming here. And this coming here. That's the travelers. Any question about that? See, you just tie the travelers between the 3-way and the 4-way switches. That's called tying the travelers. Can I have thumbs up, Chad? Just the travelers. We brought the hot to one side, and we brought the traveler to traveler to traveler. Make sense? Now let's bring the neutral. My neutral, I'm going to use green. For my neutral, guys, here's my neutral. I'm going to bring my neutral here and not tie it to anything else. It's going to come right here and just bring it here because the code requires it now to be in every switch. and from here all the way to not tied to anything else, to here. Now, Adam, I have a hot and a neutral at every one of these 3 or 4 switches. Now, what do you think? How am I going to tie that light? So you're going to take a blue, let's say it was red here actually, red from here all the way to this side. So that will be my my hot, and from this I want to go all the way to this side. Ladies and gentlemen, I can turn this light now from 3 locations. Any comments? Any questions? These guys are called these are called travelers. These are my travelers. This is the green is the neutral. Can you see that? This is the switched hot. Switched hot, right? Because I switched it. This is the hot. The hot switched hot. That's how you wire it. Now, all what you need to do, go to Karen's lab, grab what wiring method do you want? MC cable, grab the MC cable, tie it to each one of them. EMT conduit, no problem. Make sure you have the right fittings. Of course, the devil is in the detail, because if you have EMT and you don't know which type of fittings to go there, it becomes knowledge of the material knowledge. Any comments, any questions? Can you guys assure me that you're going to wire these? If you have any question, ask me. But I would like you guys to sketch them. Why do I care about this, Karen? As an estimate, you guys, designers, you will be, Derek, you're going to be an estimator at one time. You need to know how it's wired before you estimate it. Because now, gentlemen, now this is at 12.2, right? Now I'm looking at how many conductor here, right? This will be at 12.3. This here, I have 12.3, and this is at 12.2. Does that make sense when you take off? Can you take off at 12.2 as a 12.3, or vice versa? You can if you don't want to get the job. Any comments, any questions? Comments, questions? Okay, that's all what I have for you guys. I'm going to give you exactly no more than 5-10 minutes, and I really would like to go laying out receptacles and equipments and rabbits so we can get you up and running. For those of you who came late, please come on time, because I need to start on time and get you guys up and running. I don't know if the traffic was bad or bad traffic. I understand the traffic. Okay, I completely understand. But in general, please be there on time.
How much is that? 10:40. It's looking well over an hour. I think that's like a 10-minute delay.